Okay, we're going to determinant of a square matrix is what we're going to work on in this section. So we're going to learn different techniques for different size matrices. So if you have a 2 by 2 matrix, finding the determinant is really easy. A determinant is just a real number that is associated with a square matrix. The determinant matrix A, which is A, B, C, D, is notated by determinant of A, or the absolute value of A, that's read the determinant of A, or you can change the brackets for the square matrix into a straight lines, and that's read determinant of A. And then basically to do this, you take the diagonals down, the product of the diagonals down, which would be A times D, minus the product of the diagonals up. This should be familiar. And that single value is called our determinant. So the determinant A is found by taking your diagonals down, the product of your diagonals down, times by the minus the product of your diagonals up. And if matrix A is a square matrix, matrix A has an inverse if and only if the determinant of A is not equal to 0. Because if the determinant A is equal to 0, then you do not have an inverse. So finding the determinant of B here is 2 times 2, which is 4, plus 3. So finding the determinant of matrix C, diagonals down, which is 0 times 4, minus the diagonals up. And so that's going to be 2 times 3/2. And that gives us 0 minus 3, or negative 3. So our determinant of matrix C is negative 3. Okay, I want you to find the determinant of this matrix A. So again, to find the determinant of matrix A, I take the product of the diagonal down minus the product of the diagonal up. And so 6 times 3 gives us 18. Minus 2 times a negative 3, which is positive 6. So that gives us 18 plus 6 is 24. Now that we know how to find a matrix, determinant of a 2 by 2 matrix, let's see how we would find a determinant of a 3 by 3 matrix. Again, remember, it has to be a square matrix. This one takes a little bit more work. First, you're going to copy down the matrix, repeating the first 2 columns. We're going to find the product of each diagonal down, there will be 3, and then the product of each diagonal up, there will be 3. Then the determinant will equal the sum of the products down minus the sum of the products of the diagonals up. So the determinant is equal to the sum of the products of the diagonals down minus the sum of the products of the diagonals up. So let's do an example. So I'm going to find the determinant of this 3 by 3 matrix. So remember, our determinant symbol is a straight line. So I'm going to write a straight line, copy down a matrix. And then I'm going to repeat the first 2 columns. So the first column is 0, 3, and 4. The second column is 2, negative 1, and 0. So this is our setup for finding this determinant. Now I'm going to find the product of all the diagonals down. So our diagonal down, and I would suggest you use a highlighter or something because it's very easy to get lost in your rows if you don't do this. Gives me 0. Then the product, and I'm going to add the product of the next diagonal down, which is 16, plus the product of the last diagonal down, which is 0. So I have the sum of my diagonals down is 16. Now I'm going to do my diagonals up, starting at the lower left-hand corner going up. So I'm going to do the product of these diagonals, which is negative 4, plus the product of the next diagonal up, which is 0, plus the product of the third diagonal up, the last diagonal up, which is 6. Add those together and I get 2. Last step, my determinant of A is equal to the sum of the products of the diagonals down, which is 16, minus the sum of the products of the diagonal up, which is 2. So 16 minus 2, which equals 14. That's how you find the determinant of a 3 by 3 matrix. So you try the next one. Okay, to find the determinant of this matrix, first we're going to copy down the matrix, but put it in the absolute value symbols for our notation so the reader knows we're finding the determinant. Then I'm going to copy down the first 2 columns. And now I'm ready to find the products of my diagonals down. Okay, first diagonal down is 12, plus the product of the next diagonal down, which is 0, plus the product of the third diagonal down, which is 8. Adding those together, I get 20. Next, I'm going to find the product of all the diagonals up. Okay, the first diagonal up is 0, plus the second diagonal up is negative 32, plus the last diagonal up, which is 3. Negative 32 plus 3 gives me a negative 29. Then my determinant of this matrix is equal to the sum of the diagonals down of 20 minus the sum of the diagonals up, which was negative 29, so that becomes 20 plus 29, or 49. Okay, we've already learned how to find the determinant of a 2 by 2 and a 3 by 3 matrix. Now, in order to find the determinant of a matrix that is larger than a 2 by 2 matrix, is larger than a 3 by 3 matrix, we need to use something called finding the involves the minors and the cofactors of a matrix. So before we can learn this technique, we need to define what a minor is of a matrix and what a cofactor of a matrix is. So if A is a square matrix, the minor, which is abbreviated for the minor of row I, column J, for entry A sub ij, is the determinant of the matrix obtained by deleting the ith and jth row of A. The cofactor, abbreviated C sub I of j, of entry A sub I of j, is found by taking negative 1 raised to the I plus j power times by the minor of the I sub j entry, and that'll equal your cofactor. All right, that's a lot of notation. It doesn't make a lot of sense, so let's try it by example. So I'm going to look at row 1. In row 1, I'm going to find my minors. So we're going to start with our minors. So I'm going to find the minor for row 1, entry 1. So that's abbreviation row 1, 1. Okay, so to find the minors, first thing you're going to do is delete the row including that entry and the column that entry is in. So if I'm looking at the entry here, I'm going to delete what I just highlighted. So that leaves me negative 1, 2, a 0, 1. And I'm going to find the determinant of this. In this case, it's a 2 by 2. So all I have to do is diagonals down minus diagonals up. And that gives me a negative 1. So my minor for element 1, 1 is negative 1. Now the minor for my first row, second entry. So I'm focusing on this 2 here. I need to delete every entry in that row and column. So I want to find the determinant of 3, 2, 4, 1. And again, it's a 2 by 2. So product diagonals down minus diagonal up gives me a negative 5. So that's my minor for row 1, column 2. Now row 1, column 3, I'm going to delete that row and that column. So I need to find the determinant of 3, negative 1, 4, and 0. So diagonals down minus diagonals up gives me a positive 4. So our minor for row 1, entry 3 is 4. Okay, now I want to find the cofactors for row 1. So the cofactors for row 1, entry 1, row 1, column 1, is found by taking negative 1 raised to 1 plus 1, because I is 1 and j is 1, times by negative 1, because that was my minor for this entry. All right, so negative 1 to the even power is positive 1 times negative 1 just gives us negative 1. Now the cofactor for row 1, entry column 2 is negative 1 to the 1 plus 2 power, and then our minor, which was negative, times by negative 5. So negative 1 to the odd power is negative. Negative 1 times a negative 5 gives us a positive 5. And our cofactor for our first row, third column entry is going to be negative 1 to the 1 plus 3 power, and our minor was 4. So that's going to be a positive 1 times 4, which is positive 4. And that's it. That's how you find your cofactors. Now, you look at the same matrix. I want you to find the cofactors of row 3. Before you can find the cofactors, first you have to find your minors. So I'm going to find the minor for row 3, column 1. So I'm going to delete everything in row 3, column 1. I'm going to find the determinant of 2, 1, negative 1, 2. So the product of the diagonals down is 4 minus the product of the diagonal up, which is negative 1, which gives us a positive 5. Now my minor, and then my cofactor for this would be negative 1 to the 3 plus 1 power times by our minor of 5. So that gives us a positive 1 times 5, which is just 5. Now I'm going to find the minor for 3, 2. So this time I'm going to look at my third row, second column entry, which is the 0. And then delete all the rows and the columns, and that row and that column. That leaves us with the determinant of 0, 1, 3, 2. And the product diagonal down is 0, minus the product diagonal up is 3, which gives us negative 3. Now our cofactor for 3, 2 is negative 1 to the 3 plus 2 power times our negative 3. Well, negative 1 to the 5th power is negative 1 times a negative 3 gives us a positive 3. Now I'm going to find my minor for my 3, 3, or our row 3, column 3 entry, which is the 1. Deleting the rows and columns that is in leaves me with finding the determinant of 0, 2, 3, negative 1. So the product of my diagonals down is 0, minus product of my diagonals up is 6, which gives me a negative 6. So my cofactor for 3, 3 is equal to negative 1 times by, raised to the 3 plus 3 power times by negative 6, which gives us a positive 1 times negative 6, which is negative 6. And that's how you find your cofactors. Now, why did we have to learn how to find cofactors? Well, cofactors have to be used in finding the determinant of any square matrix larger than a 3 by 3 matrix. So 4 by 4 matrix or higher, you'll use the process of finding a expansion by cofactors method. So you define a row to focus on, and you can pick any row you want to focus on. It does not matter. But I will tell you, the easiest one is to always pick a row that has the most zeros, because zeros always easy to work with. And if you have a couple rows that have the same number of zeros, then look at the numbers, which ones have smaller numbers, like ones, if ones have ones in them, something that's easy to multiply by. Once you define which row that you're going to work with, the determinant of a square matrix is attained by multiplying each element of the chosen row by its cofactor, and then adding each of those results together. Here's our matrix. I want to find its determinant. So I'm going to choose a row. Now, row 2 and row 3 both have zeros in them, but row 2 has a 1 and a negative 1. So it has a 2, which is a smaller number than the row 2. So I'm going to choose, because of that, I'm going to choose to do row 2. So that's my chosen row. Now, it really doesn't matter which row you choose. You'll get the same answer. It's just a little bit easier math to work with. So I've chosen row 2. So my first step is to find my cofactors for row 2 of this matrix. So if order to find cofactors, we first have to find minor. So I'm going to find the minor for row 2, entry 1. And so that means I'm going to delete that row and that column. So it tells me I need to find the determinant of -2, 4, 3, -1, 0, 3, and 7, -8, 1. Now this is a 3 by 3 matrix, so I need to copy down my first 2 rows and then find the product of my diagonals down and sum those together, and I get 108. Now I need to find the products of my diagonals up and sum them together. And remember, last step of finding our determinant is we take our diagonals down minus our diagonals up. So my minor for row 2, entry 1, is 64. So my cofactor for row 2, entry 1, is -1 to the 2 plus 1 power times 64. So 2 plus 1 is odd, so it's going to give me a -1 times 64, which is -64. Okay, now I'm going to repeat this for our next entry. So I'm going to find the minor for row 2, column 2.
Our determinant of a square matrix is found by finding the determinant by multiplying each element of our chosen row by our cofactor. So if our element is 0, multiplying 0 by whatever our cofactor is for our entry gives us 0. So we can skip this one and move straight on to our minor for our second entry, third column.
And that's going to be another 3 by 3 matrix. Again, I need to copy down my first 2 columns in order to find the determinant of this 3 by 3. And the determinant of 3 by 3 is found by taking the product of the diagonals down and summing them together. And then subtracting the products of my diagonals up, summed together. So my minor for row 2, entry 3, row 2, column 3, is equal to 37. So my cofactor for our row 2, column 3 would be -1 to the 2 plus 3 power times 37. 2 plus 3 is odd, so it's going to be -37. I need to find the minor for my second row, fourth entry. So I'm going to delete my second row and my fourth column and make a determinant, find the determinant, what's left over. So remember, a determinant by a 3 by 3 matrix, I find the product of all diagonals down and add them together. Minus the sum of all the diagonals up. So therefore, my minor for my second row, fourth column is 164 minus 64, or simply 100. I still have not found everything, so I need to find my cofactor for this. So that's going to be -1 to the 2 plus 4 power, which is an even number, so it's going to stay positive, so that's going to be 100, because I times that by my minor. My last step is to take each of these individual cofactors and times it by my element entry for that row. So for example, my entry for row 2, column 1 is -1. So I'm going to take -1 and times it by the cofactor for -1. And the cofactor is here in the red, which is negative 164. Then I want to take the 0, which I don't have to do, so I'm going to switch over to the 2. And that is my row 2, column 3, so I times that by its cofactor of negative 37. And then I take plus 1 times by its cofactor of 100. And then I'm going to add these all together to get the determinant of my original matrix, which is 90. So the determinant of matrix A is 90. Now, remember I said you can do your chosen row, and it really doesn't matter which row you're going to choose. Let me show you how this doesn't make a difference. Now, remember that example that we just did where I found row 1, then you found row 3? So let's find the determinant of this matrix using my row 1. So determinant of matrix act. So row 1 is, first entry for row 1 is 0. So I'm going to take 0 times its cofactor of negative 1, plus my second entry in row 2 is 2 times by its cofactor of 5, plus my third entry for row 2 is 1 times by its cofactor of 4. So that gives me 0 plus 10 plus 4, or 14. Now let's check and see if you have chosen row 3, because these could equally be chosen. So finding the determinant of matrix A, looking at row 3, what I would do is I say, okay, the determinant of matrix A is equal to my element in row 3, which is 4, times by its cofactor of 5, plus my second entry in row 4, which is 0, times by its cofactor of 3, plus my third entry, which is element, which is 1, times by its cofactor of negative 6. So that leaves me with 20 minus 6, or 14. So notice it doesn't matter which row you choose. Just choosing a row with 0 saves you some time, and with ones are a lot faster. But it really doesn't matter which one you choose. It's just how much work you want to do. So now we know how to find all these determinants. We're going to learn a new way of solving systems of equations. And this it's called Cramer's rule. Cramer's rule allows us to use determinants to solve systems of equations. Now we're going to make a few determinants here. Well, the determinant of x is found by the determinant of the x values divided by the determinant of the coefficient matrix. Y is equal to the determinant of the y divided by the determinant of the coefficient matrix. And z is equal to the determinant of z divided by the determinant of the coefficient matrix. And this repeat for all variables that you have in the matrix, however many that you have. So notice that our determinant A stands for the determinant of the coefficient matrix. And our d sub x is our determinant with the x. And d sub y is determinant with the y. Now, of course, if the determinant of the coefficient matrix is 0, then the equation will either have no solution or infinite many solution, and you'll probably need to solve this another way. All right, so starting with our Cramer's rule, I'm going to do this first example. So I'm going to set up my determinant A. And remember, determinant A notation stands for the determinant of the coefficient matrix. So our coefficient matrix would be matrix 4, negative 2, 3, negative 5. So I want to find the determinant of that matrix. I'm going to just do determinant of 4, negative 3, negative 2, 3, negative 5. So this is 2 by 2 matrix. So I just do the product of the diagonals down minus the product of the diagonals up. And that determinant is simply negative 14. Now I'm going to find the determinant of x. Now, the determinant x, you look at your coefficient matrix. Now, notice my first column lined up with my x variables. My second column lined up with my rows. Now, when you do your determinant x, you replace your x column with the answer to the system. So notice my y column stays the same, but my x column becomes 10 and 11. And then you just find that determinant. Negative 28. So to find our determinant y, you probably guessed you're going to do the same thing as we did before. We're going to go back to that coefficient matrix, and we're going to replace our y column with our answers. So the x column goes back to 3 and 4. Now the y column is now 10 and 11. And then we're going to find that determinant by diagonals down minus diagonals up. And then our last step is we're going to do those fractions. So x is equal to, the variable x will equal to the determinant of the x matrix divided by the coefficients determinant. So determinant x matrix is negative 28, determinant of the coefficient matrix is negative 14, divide that, I get 2. So x is equal to 2. Y is equal to the determinant of the y matrix divided by the determinant of the a matrix. In this case, that would be 14 divided by negative 14, which gives us negative 1. So therefore, our solution to this system is the point 2 comma negative 1. All right, I want you to try the next system. Solve it using your Cramer's rule. Solve it using Cramer's rule. Step 1, we need to find our determinant matrix, our coefficient matrix. So that's going to determinant of the coefficient matrix, which is negative 11. Now we need to find the determinant of the x matrix. So remember, we're replacing the x column with our answers, keeping the y column the same, and then finding this determinant, which is equal to 11. Then we're going to find the determinant of our y matrix. So we're going to go back to our coefficient matrix, but this time replacing our y column with our answers. And finding its determinant by doing our diagonals down minus our diagonals up. And that gives us negative 44. So our variable x is going to be our determinant x divided by our coefficients determinant. And that's 11 divided by negative 11, which is negative 1. Y is going to be our determinant of the y matrix divided by our coefficient matrix. And so that's negative 44 divided by negative 11, which is positive 4. So my solution to this system is negative 1, 4. Now I can do this with any size system. If it was a 3 by 3 matrix, I would do the same thing, except when I find my determinants, I'm going to have to use our 3 by 3 method.